Hey everyone, and welcome back to another CTF Reddit video. Today I'm going to be covering the web challenges as part of WaniCTF. WaniCTF is hosted by the Osaka University CTF team, and overall, just a really good CTF, very quality. I've had no issues, good challenges, more beginner friendly, like educational style CTF, but just amazing. Like I've had zero issues. I'm going to be covering these web challenges. I didn't solve the last one. Once I hear what the solution is, I'll put it in the comments, but I'll be covering the first 7. And like usual, I'm going to be going pretty fast. If you have any questions, feel free to either leave it in the comments. You can reach me on Discord. I'm Conrad, Twitter, email, anything. Always happy to chat. And with that, let's get started. The first challenge is IndexDB. IndexDB is a feature built into browsers. And so if we actually just inspect the IndexDB for this page, we can see there's a flag here. So you just go to Application, IndexDB, TestDB, and then the name of this object store, and the flag is here. If you view page source, the flag isn't here. Let me close. If you view page source, there's nothing here. That's because this did a redirect. You can see it's 1 indexed instead of an I here. So to ignore the index, you can just curl the web page. So we'll do, let me go back, grab the original. If we do curl, and we go to the root, this will not follow the redirect, and so we can see this is the code that actually puts the flag into the object store, and the flag is also right here. The next challenge is extract service. We're given a URL and a download file. If you open up the zip file, it contains the source code. It's written in Go, and the idea behind this web app is it's a extract service, and so you give it a zip file and the file you want, and it'll extract your zip and then just give you a file. Thankfully, that file doesn't have to exist within the zip file, so you can just request any file you want. And so the solution was to just, this is the solution. So we're going to upload a file. It can be anything. We don't actually use it. We just need to make sure that the unzipping process goes correctly. So I just gave it one of the sample files that was already in the challenge. And then when we say what file we want, instead of specifying some file within the zip doc format, we just specify that we want the flag. And so let's run that, Python 3, solve.py. And here's the flag. Extract is broken by bad parameters. The next challenge is 64 bytes per second. We're given a URL and a zip file. If we extract the zip file, it's pretty simple. There's a Docker file, which is just based off of Nginx, and it's going to construct this 2 GB.txt file, so a very large file, and it's going to add the flag.txt to the end of this text file. So we just have a single 2 GB text file sitting there. If we look at the Nginx config, we can see that it has some rate limiting. And you can only download at 8 bytes per second. So for a 2 GB file, that would take a very long time. Thankfully, Nginx respects all the standard HTTP headers. And so what we can do instead is just use the range header. And so the range header, standard HTTP header, it allows you to specify little chunks of a request. And so what we're going to do is we're just going to ask for the last 60 bytes of a request, and hopefully that has the flag. So if we come back to this URL, let's copy this over. We're just going to use curl. So we're going to go curl, capital H. We want the range header, and like I said, we want the last 60 bytes. So it'll look like this. Then we paste the URL. Oops, didn't copy. Copy. It still takes a couple of seconds, so we have to wait. And there we go. We get the flag. It says make use of range request for large files. The next challenge is extract service 2. So in this challenge, they fixed the previous bug. So in extract service 1, we gave the website a zip file and we requested a specific file, and the web service would unzip the zip file and then return an arbitrary file, and that was the bug. For this one, we're no longer able to specify an arbitrary file. Instead, previously we passed target, and target would be any file on disk. Now, when we pass it, it's either doc, Excel, a spreadsheet, or a PowerPoint. So we don't have much control there. At first, I was worried this was going to be an XXE, but thankfully they don't do any XX or XML parsing, so it's not that. This is more of a zip slip sort of vulnerability. And so the trick is they're going to unzip everything, but we can still pass symbolic links. So what we're going to do is we're going to pass a zip file that has a symbolic link to the flag, such that word./document.xml is a symbolic link to /root flag. And so that way when it returns this specific file, it'll actually return the flag file on disk. To do this was my solve script, import request, import OS. I do OS system. I create this symbolic link. So like I said, I'm going to link a file called word document.xml to this /flag. And so this file, symbolic link, it doesn't actually exist. It just points to the /flag file on disk. Then I'm going to create that zip file. When I create the zip file, I'm going to specify that I'm using symlinks, and I'm going to zip in just this word/document.xml into sample.zip. Then I'm going to make a standard post request. Just here's my files. There's one file called file. Then my values, the target is a document. This is just a document. And then I make the post request, and I should print out the response. And if we run it, we should get out the flag, and here it is. Extract is broken by symbolic link file. The next challenge is screenshot. It says an application that takes screenshots of your favorite websites. We're given a URL and a zip file. If we open it up real quick, we can see it's just google.com. We click this take a screenshot button, make it a little bit bigger, and we're given a screenshot of google.com in Japanese, which is pretty fun. If we look at the source code, there's just that route, the get screenshot. And basically what this code is going to do is it's going to spawn some sort of like Puppeteer sort of thing. They use Playwright, which I wasn't familiar with, but it seems very similar to Puppeteer. It's just a web driver for Chrome. And they do this validation here. So you specify a URL. And so they're going to check, make sure that the URL contains HTTP and that it does not contain file. And the idea here is they're kind of hinting at I guess a file inclusion or server-side request forgery sort of bug where maybe you could specify file flag.txt, which would be bad. But because of this check, obviously we're going to bypass this in a second. This doesn't seem possible because it needs to include HTTP and it cannot include file. But anyways, then it's just going to create a new page. It does this. Oh, normally this wasn't here. It then loads new URL search params. It grabs one of them, and then it grabs that URL, just the param URL. So thankfully, the bug is not too bad. Oh, this console log wasn't here either. But what we're going to do is we're actually just going to pass two URL parameters. And so if we do that, so it's like host, something like that, we're going to pass URL is equal to A and URL is equal to B. So like I said, we're passing two of them. The way Node.js is going to handle this is it's going to create an array like this. So thankfully, includes works on both strings and arrays. So we could just set one of these to HTTP like this, and the other one will not contain just the string file. It can contain a file blah blah blah. That's totally fine. It just can't be only file, which it won't be. So at this point we can just do flag.txt. And yeah, that's the bypass. So let me just copy out the solve. This was it, screenshot, API screenshot URL file, flag, and URL HTTP. You had to make sure to get the order of this correctly. I mean, if you mess it up, you just swap it. You want to make sure that URL equals HTTP is at the end. But we go over here, and it should take a screenshot of flag.txt, and there we go. Beware of parameter type confusion. The next challenge is certified 1. We're given a URL and a zip file. If we go to the URL, we're able to upload a file or an image. I'm going to upload the Sloppy Joe Pirates logo. Click open, I click upload, and it is approved by Dr. Wani, which is what the challenge said. This says approved by Dr. Wani, so thank you, Dr. Wani. And that is the challenge. So if we look at the source code, there's a bunch of Rust files. Most of it aren't too exciting. The exciting thing is right here. At some point, it's going to process the image to add that stamp. And to do that, they use ImageMagick. ImageMagick has a whole bunch of bugs, just because it's doing a lot of complex parsing and stuff, so it's a natural target to have a lot of bugs. And there was a recent bug. It was a LFI, a local file inclusion. And so by specifying I think it's like a text element within the profile metadata, it'll return the file on disk, which is pretty crazy. But thankfully, we don't really have to even know how it works. We're script kiddies, so we're just going to download an exploit off the internet. I found this one, ImageMagick LFI POC. You just copy it out, generate.py. So I took this and I copied it over. Just renamed it to ImExploit, ImageMagick exploit. And to run this, you give it a local file. So this will be our PNG, the file that you want to read. And then you just specify an output file, and it'll create this POC for you, which is pretty awesome. So I wrap this into a solve script. This is the solve script I'm using, so I specify the host. I run that exploit. So I'm going to say Python ImExploit, that thing that we got from GitHub. I'm going to request the file called flag_a and output exploit.png. From there, we just do standard request stuff. We're going to upload that file. Nothing too exciting. We're going to grab that location header. I download it and I save it to disk. And then I run exiftool on it. Exiftool gets you the metadata for an image. I specifically just search for the profile word, and then the response you get is in hex. And so I just do a little bit of Python stuff to print out the hex. You didn't need to do all this. This is kind of overkill, but it's useful for part 2. There's a certified 2 challenge, and the script kind of helps let you search around. But if we run it, Python 3 solve1.py, running the scan, downloading the file, downloading, and there we go. Flag, the second flag is waiting for you. The final challenge that I'll be talking about is Lambda. This challenge, it's not difficult if you've used AWS before. Basically, the idea is on the back end, there's the Lambda service. Lambda is just a way to execute code in the cloud. It's nice because you pay for invocation, not for server hosting. But anyways, there's this little login page. And if we view the page source, there's login.submit. And we can see that eventually it's going to execute this URL. So this execute API tells us that they're using API Gateway, which is another feature on AWS. This gives us the ID, which is useful. We get the region. And as part of the download file, they give us some credentials. And so they give us this. And so these are AWS access key, secret key, and region. All super useful things. And so this is a web challenge, but really it's more of just like an AWS challenge. And so our job is to take these keys and kind of dig around and see if we can figure out how this Lambda function works. So like I said, if you're familiar with API Gateway, this challenge really wasn't too bad. If you're not, this challenge might have been kind of difficult. But to do this, basically just start scanning. So there's this AWS CLI. This is how you call it. This is one way to call it. This is the insecure way to call it. If you're writing real code for a company, don't pass it with environment variables. You should be using profiles or some sort of key management system. But we're going to use environment variables because we're playing a CTF. And so you pass the AWS access key, you pass the secret key, you pass the region, and then you say this is the AWS, so this is the start of the actual command, this is the CLI tool. And so we're going to say API Gateway, get me the resources with this REST API ID. Like I said, we got this from the page source right here. So this is like our starting foothold. Sometimes you're allowed to just like request, like we could just go to AWS Lambda get functions, but we don't have permissions to see all the functions. And so we need to figure out the specific function name so that we can query it. Once we have the function name, it's very easy. So first step is we're going to query this API gateway since we know what the name of it is. We're going to see what functions it has attached. And then from there, we'll be able to see the source code and then figure out what the flag is. Anyways, first step, we're going to get the resources on this API gateway. We have a resource here with this ID and a resource map method for get. Cool. And I just wrote these down here. So we have a REST API ID from the page, and we have a route ID, which is this one. From here, I just started poking around. This one wasn't exciting. I also looked at deployments. I was just curious to see if there was anything here. Basically, to do this, you just go to the AWS docs and you search AWS CLI API Gateway, and it'll give you, actually, we'll just do that. AWS CLI API Gateway, and it'll give you a list of all the commands. They're kind of like, they kind of follow the CRUD syntax, create, read, update, delete. So we can see we have create, we have some delete. They have a bunch of gets in here. And so you can see where my blues are. I pretty much just clicked on things that I thought would be interesting. So the get resources, get integration. That's what I thought would be useful. And then once you click on these, so eventually we're going to use get integration. It tells you what it needs. So it needs a REST API ID, a resource ID, and an HTTP method. That's the one that's actually useful. So I looked at deployments, not too useful, blah, 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 blah. This is the first call that's actually, or the second call that's very useful. So we're going to ask for integrations. So API Gateway is kind of like this glue. So a HTTP request comes in, it gets parsed, and API Gateway will kind of point it to the correct resource. In our case, that's a Lambda. So in this context, a Lambda is an integration. So we're going to pass it the REST API ID, which we have from the JavaScript, the resource ID, which we got from the resource call, and the method. And when we do that, we can just run it real quick, even though the response is right below. And if we take a look, we have this URI, and this URI has the function name. So this is what we wanted. It was just Wani function. We probably could have guessed that or brute forced it, but better just to do it this way. So we'll copy that out. Now we can make a call to Lambda, which is the one down here. So we're going to, oops, not this, this one. We're going to do AWS Lambda get function. And now that we have the function name, it'll return us information about the function. So we'll run that real quick. Cool, and it's very long. And that's it. Here is the code as part of the response. And so we can go here and download the code object. It's just a zip file, and it contains a bunch of stuff. To make the challenge more fun, the challenge authors, I guess, decide to write it in .NET. So we get a bunch of .NET DLLs. And you can kind of see some of them here. We have Amazon Lambda API Gateway, core, serialization, Newtonsoft, which I guess is a library for doing this stuff for JSON. We also get this one, the WaniCTF Lambda.dll. This is the one that contains the function that actually responds to our web request. To load this, I used a tool called dnspy. You have to run it on Windows, so I ran it on my Windows computer, and I don't want to boot up my Windows computer for a video, so instead I just took a screenshot. Let's see if I can make this bigger. But dnspy, it's great for these .NET reversing challenges, which is what I normally use it for, and it pretty much just gives you back the raw source code. I wish it worked on a Mac, but it doesn't. But anyways, if you open up the source code, if you've never used it before, you just open the file. It's really not too bad. You just kind of click through here. So we're WaniCTF Lambda. You click through here, WaniCTF Lambda. Then you click on the function. And if you just kind of scroll around, you can see that it's doing some proxy stuff. And here it's going to ask for username. Here it's asking for password. If it matches these two things, it'll return with the flag. We don't actually have to make the request. We can just copy out the flag, and that was it. So pretty fun challenge. And that is all the challenges I solved. I didn't solve Certified 2. I'm a little bit confused. It doesn't have that many solves, and it's marked very hard, so the solution I thought would work obviously did not work. I thought that you could just request proc1 environ. The flag is on the environment variable, so I thought you could just request the environment variable for the web server, but it comes back as empty. It doesn't crash. Like if you request a file that doesn't exist, it gets mad and throws an error. So the file exists, is just empty, which is a little bit confusing. But if I cat out the file locally, it does have contents in it. So kind of confusing. I'm very curious to see what the write-up is. If I figure out what the solution is, I'll put it in the comments down below. But yeah, that's all the web challenges. Very amazing CTF, especially for a university CTF. Great challenges, had a lot of fun, no infrastructure issues, source code was provided. So yeah, I had a great time. So thank you, and I'll see you at the next CTF. Cheers.